So let's take a look at the regular join again. So now we have a course and instructor join, right? And what we do is we have a join crossover from course join instructor on instructor name equals to instructor name. This on clause basically tells us what should it be left, should it be kept, right? It's going to be when two tables, when T1 dot the instructor name equals to T2 dot the instructor name, then that's a match. This tells us what table to, what the row we should, what the row combination we should keep. Now, what if we forgot the on clause and write something like select star from course join instructor without the on? If without the on, it's similar to a join without a where clause or any SQL operation without a where clause. So what's going to happen in SQL execution? As we said again and again, SQL execution is going through each row in the table, right? We will go through each row in course table. Then for each row in course table, we will go through each row in instructor table. For each row to row matching, course row to instructor row matching, because there is no on clause. There's no where condition, no join condition, no such a filtering condition. We assume this row combination, course row and the instructor row combination meets our requirement for SQL operation. That means that each row in course will match with each row in instructor. If a course have m rows and the instructor have n rows, then we will end up with m times n rows in the final join result. All of them matches the requirement, which is none. We don't have requirement, so all the rows match the requirement, the joining condition. And this is called the Cartesian join, also called the cross join or Cartesian product. As you can see, this Cartesian join can quickly get dirty when you have a large set of data in a table. If you have 1 million rows in course table and 1 million rows in instructor table, you will have 1 trillion rows in the table, right? A million is 10 to the power of 6. Then once you have two 1 million table joining, cross joining, you will have a 10 to the power of 16. So because of this, modern database usually don't allow you to do this. When you write a join, you have to have an on matching. Unless if you really want to write a cross join, you will need to write from table 1 cross join table 2. That's the only way only place where you can actually have a cross join. If you do not have this keyword cross, only write a join, then you have to have an on. You cannot have a join without the on. So I'm not writing cross join here because this is not recommended. And the other way you can do cross join, however, is to use a where, write from with all the courses, with all the tables in the line with comma. So that you don't have a join, so you don't need to write the on. And if you do not write the where clause, then you will have a cross join. So either way, if you write a cross join, that means you intentionally want to do cross join. So SQL is okay with that. Or you use the old syntax where SQL is not capable of handling, you will be on your own. But in general, you should write join and on. You should not ignore this on condition. Resulting in most cases, this is a mistake. Right? In most cases, you should join with a condition. Now, there's also something called a partial cross join. If both sides are not unique, notice here is both sides are not unique. Its value, join value from both sides are not unique. What you will have? You will have a partial cross join, because, for example, instructor table joins itself in the affiliation column. if I want to meet all the instructors with the same affiliation of mine, then I will use my Jedi to join all the Jedi, or I'm going to use the Sith to join all the Sith. If I have 3 Jedi, I'm joining the same instructor table with 3 Jedi. This will be a M times N. This is the 3 by 3 connection. It will be 9 rows returned, right? Or if I'm a Sith, I have 2 Siths. 2 Siths joining 2 Siths. M by N is a 2 by 2 equals to 4. 4 rows will be returned. So you can see that within each value, within each non-unique value join, you will still have an M by N cross join. However, you do have a condition somewhere. So it's not a completely full cross join between these 2 tables. That's why it's called a partial cross join. Let's go through a quick example. Let's say we have this table 1, right? And we have table 2, and we are doing from table 1 cross join table 2 without on, right? From table 2 cross join table 1. Now, for table 2, first row in table 2, I'm going to compare this ID to ID joining table 1, so ID 1, right? Because ID 2 is 1, I'm going to get a match when the first row of table 2 matches with the first row of table 1, which is this one. Now, I'm going to match the first row of table 2 with the second row of table 1, which, because both values are 1, I'm going to get another match. And then 1 and 2, of course, is not matching, so I'm going to skip it. But then let's go to the second row of table 2 and use this to match all the rows in table 1. The first row, of course, 1 and 1 is a match, so I get this 1 and this 1 more. And the second row of table 1 will match the second row of table 2, which we will get this. So because I have 2 1s in table 1 and 2 1s in table 2, we have the same value in both tables. We have a multiple same value in both tables. So we get M by N number of resulting rows, which is 2 times 2 here, getting 4 rows. So as you can see, the only way that it can avoid this partial cross join, or eventually avoid the join, is to make sure you are joining on a column that at least one of them is unique. Because as you can see, it's M by N. If either M or N is 1, then there's no cross join, right? So either M or N has to be 1, which means either column, any one of them must be unique. And the most unique key the column we know, of course, is a primary key, right? So this is what do we say here? The join key, which means the column used to join, usually should be the primary key of one of the 2 tables. Now you cannot, we don't expect the join key to be the primary key of both tables, because in this case, then there will be just a 1-to-1 matching. That usually won't happen. But in most cases, the join key will be the primary key of one of the 2 tables, which will avoid the cross join or partial cross join. So this key is called the foreign key on the other table. So it will be primary key of one table and the foreign key in another table. The foreign key of another table, I should say. So if I'm joining instructor with the course have an instructor name, but the instructor name can repeat for different course, right? Now, within instructor name is the primary key, right? And the instructor name is the foreign key on the course table. Course table is referencing a foreign key in the is referencing the instructor table's instructor name as a foreign key. Let me repeat. Course table is referencing the instructor name column in instructor table as a foreign key. So this instructor name table, so this instructor name column is the primary key for instructor table. It's also the foreign key of course table. If it's not a primary key, so it's easy to remember, it's either a primary key or it's a foreign key in the table that it is not a primary key. Apparently the instructor name is not a primary key in the course table, right? So it's a foreign key.